Hippocrates, one of his most quoted statements is, let food be your medicine and medicine be your food. So what I'd like to look at is how food affects diabetes and high blood pressure. And never in the history of mankind have human beings eaten so many carbohydrates. So let's do an assessment of the carbohydrates that Australians are eating. And no matter where I go in the world, in America, in Scotland, in England, in New Zealand, it's the same. So most people have cereal for breakfast. We know because there's a whole aisle devoted to it, and also bread. There's a whole aisle devoted to bread. And if you go into the supermarket and see a whole aisle devoted to something, you've got a pretty good idea that it's a hot topic, eh? It's something that a lot of people buy. And cake shops abound, cakes, biscuits, so we'll say cakes, etc. And pies, Australians love their pies. Pizzas, Italians have introduced Aussies to pizza and pasta. I'm a fifth generation Australian, Scottish descent. I didn't know what pasta was till I was about 18. I don't think there's a home without pasta today. Rice is another carbohydrate. I'm married to an Irishman, so every main meal must contain potatoes. Michael and I went to Scotland last year, 2017 in June, and Michael was so happy because we ate in English pubs, and in the food there's about 3 or 4 different types of potatoes. Lots of potatoes. They have lots of veggies too, that's why we could eat there. And last and certainly least in nutritive value is the pure crystallized acid that's extracted from the sugarcane plant. Would you agree with me? Aussies are high carbohydrate consumers. Now all of these foods in the gastrointestinal tract, which I will show you tomorrow night, they break down to a singular structure called glucose. So when these foods get broken down to glucose, the glucose gets into the blood, and then it goes on the main highway straight to the project manager, which is called liver. And we're going to look at that a little bit in the next lecture. But the liver sends it, first of all, to the CBD, Central Business District of the human body. And that glucose goes into the cell. And when the glucose goes into the cell, it goes under the action of insulin. Insulin is the key that unlocks the door to get glucose into the cell. It then goes through a 20-step pathway, 20 little chemical reactions, which delivers to us 2 units of energy. The end result of this 20-step pathway is a chemical form of glucose called pyruvate. Pyruvate, as the chemical form of glucose, gets fed into what's often called the powerhouse. Called the powerhouse because even though it's only an 8-step pathway, it delivers to us a whopping 36 units of energy. So what makes the difference? How come an 8-step pathway gives us 36 and a 20-step pathway only gives us 2? The difference is oxygen. So this is what's often called an aerobic pathway, meaning it uses oxygen to produce energy. Whereas this pathway is called anaerobic. Anaerobic meaning no oxygen. It actually produces energy by the process of fermentation. So the first place that the glucose is sent is to the cell to be burnt as fuel. That's not a surprise. But on a high carbohydrate diet, there's still a lot of glucose left over. And so now the liver causes some of it to be stored in the cell like a little bunch of grapes, but they're little molecules of glucose. And they're stored there for when we need them. And they're called glycogen. Glycogen is a name given to quick-release glucose stores. This explains why when you wake up in the morning and do your morning exercise, you don't need to eat first. You will get energy because inside your cell, particular muscle cell, there are little molecules of glucose just waiting to be plucked when the need arises. But on a high carbohydrate diet, we've still got glucose left over. And so now the liver causes that excess glucose to be stored in the most amazing fuel depot in the human body, fat. And on this high carbohydrate diet, what's happening to Australians? They're getting bigger and bigger and bigger and bigger. Fat doesn't make you fat. I've just given you the basic science here. What makes you fat? It's the glucose. It's the carbs. And here we've got our pancreas. And our pancreas, it releases two hormones. One is insulin, and insulin's the hormone designed to get the blood glucose down again when it goes high. And if it goes down, if the blood glucose goes too low, then glucagon is released. And glucagon is the hormone that's released if blood glucose goes too low to get it up again. Now what's happening with the pancreas is when the pure crystallized acid extracted from the sugarcane plant goes in, blood glucose levels rise dramatically. Not sugarcane, because in the sugarcane, the glucose is all bound up in fibre and it slowly releases the glucose. But that pure crystallized acid that's been extracted from the sugarcane plant, when it goes into the body, blood glucose levels go boom. Very quickly the brain says, overload, quick. Pancreas, release the insulin. You see, high glucose demands high insulin. And so now the insulin's released and blood glucose levels start to drop, because now the insulin causes the glucose to go into the cell or to be stored as glycogen or fat. But because there was so much glucose, huge amounts of insulin are released. So where are blood glucose levels going now? Too low. That's called hypoglycemia, too low. So now the brain goes, oh no, we're too low. Stop the insulin, release the glucagon. But by the way, what happens down there? What does the person do? I need a hit of sugar. I'm too low. Will the sugar get it up? Oh, absolutely. Boom! Oh no, we're too high. Stop the glucagon, release the insulin. Oh no, can you see what's happening? Something else is happening. The cell starts to say, I'm sick of the sight of your insulin. And insulin resistance sets up. I'm sick of the sight of you. So the cell starts to resist insulin. And the blood glucose levels stay high because it's resisting getting in. And so the brain says, too much glucose, more insulin, more insulin. Can you see what's happening here? The body says, what am I going to do with this? Get it out through the urine. Do you know what diabetes mellitus means? Sweet urine. Because there's nowhere else for it to go. And then eventually the pancreas just says, I'm sick of this. I'm done. And it just stops releasing the insulin. We had a young man named Paul do our program. He was 19. He had type 1 diabetes, and he'd had type 1 diabetes since he was 15, where he was put on a very strong course of antibiotics for a chest infection, and it started to kill off the beta cells in his pancreas that produce insulin. See, there can be several causes. He came to us. He was actually quite overweight for a young man. You see, high insulin, you know, insulin's got a one-track mind. I must store, I must store, I must store. I've got to get it out of the blood and store. It's very hard to lose weight if someone's on high insulin. So he was on 90 units of insulin a day. He came to our program. He heard the lecture on how the carbohydrates, They're the ones that dump us glucose, get the blood sugar level too high. First 2 days at Misty Mountain Health Retreat, our guests have juices, mostly carrot, celery and apple juices. In the middle of the night, his blood sugar started to drop. What does that mean? He's on too much insulin. So the first week, he would have a lolly. That would get the blood sugar level up again, but he'd always get a headache because it'd go boom. Oh. Second week, he got convicted he shouldn't have the lolly. He was a quiet guy. I didn't know what was happening in the middle of the night. Second week, he decided to eat an apple. It takes a long time to eat an apple in the middle of the night. And to get the blood sugar level up, but he wouldn't get the headache. Third week, instead, if he got a blood sugar level low, he wouldn't take a lolly, he wouldn't take an apple, he'd jump down on the floor and he'd do 30 push-ups. And it'd get the blood sugar level up. Where'd that come from? His glycogen stores already sitting in his muscle cell. In fact, he told me he got up one morning, his blood glucose levels were 3.5. That's nearly passing out. He took that bit of salt, put it on his tongue, had a glass of water, went to the bathroom, had another glass of water, put his joggers on and went for a run, running up and down hills. Came back, took his blood glucose levels, 9. Where'd that come from? His glycogen stores, and if they ran out, he's got more. It's called fat stores. That's what the liver can do. It's called gluconeogenesis, producing glucose from fat stores. He said to me in the third week, he said, why didn't anyone tell me about glycogen? Glycogen. It's the diabetic's best kept secret. Notice what releases it, making sure you're well hydrated, exercising. By the end of the third week, he dropped his insulin by 90%. He was eating a very low carbohydrate diet. So what was he eating? Lots of vegetables. Legumes, every meal. Brown rice, whole grain spelt flour. He was an excited young man. He did 2 weeks program and 2 weeks in the garden, so he's with us for 4 weeks. He was so excited.
After gaining valuable insights from Barbara about the secrets of diabetes, let's dive deeper into the relationship between the pancreas, insulin, and gluconeogenesis. The pancreas is a vital organ located behind the stomach. It has 2 main functions, producing digestive enzymes and regulating blood sugar levels through hormones. One of these hormones, insulin, plays a crucial role in maintaining a stable blood glucose level. Inside the pancreas, clusters of specialized cells called the islets of Langerhans are where insulin is produced. The beta cells within these islets are like vigilant guards, constantly monitoring blood sugar levels. When we eat, glucose from food enters the bloodstream, causing blood sugar levels to rise. Beta cells spring into action, releasing insulin into the blood. Insulin acts as a key, unlocking cells in the muscles, liver, and fat tissue to allow glucose to enter. This glucose is then used as fuel for energy, stored as glycogen in the liver and muscles, or converted into fat for later use. This process ensures that blood sugar levels return to a healthy range after a meal. When this system is disrupted either because the pancreas doesn't produce enough insulin, as in type 1 diabetes, or the body becomes resistant to insulin, as in type 2 diabetes, blood sugar levels can become dangerously high. Understanding this relationship is crucial for managing diabetes and other metabolic disorders. Now, let's talk about gluconeogenesis. The name might sound complex, but the process is straightforward. It's the body's way of creating glucose when dietary sources are unavailable. This metabolic process takes place primarily in the liver and, to a smaller extent, in the kidneys. Gluconeogenesis kicks in during periods of fasting, intense physical activity, or when carbohydrate intake is low. After about 12 to 18 hours of fasting, the liver's glycogen stores body's immediate source of glucosylceramide depleted. To prevent low blood sugar, the body switches to gluconeogenesis. The process uses non-carbohydrate materials like amino acids from protein breakdown, lactate, a byproduct of muscle activity, glycerol, released from fat stores. These raw materials are converted into glucose, ensuring that energy-dependent organs like the brain and red blood cells continue to function. Specialized enzymes orchestrate gluconeogenesis. Pyruvate carboxylase and PEP are two major players, transforming precursors into glucose. This process requires energy, supplied by ATP, which the body generates from fat stores. Gluconeogenesis is vital for maintaining blood sugar balance during fasting or low-carb diets. It prevents hypoglycemia, a condition where blood sugar levels drop to low, which can be life-threatening. The process is tightly regulated by hormones. Glucagon and cortisol stimulate gluconeogenesis when blood sugar is low. On the other hand, insulin suppresses gluconeogenesis when blood sugar levels are adequate, ensuring balance. The pancreas and insulin work in harmony with gluconeogenesis to regulate blood sugar and energy. Together, these processes ensure your body has a steady energy supply, no matter the circumstances. Understanding the relationship between the pancreas, insulin, and gluconeogenesis can empower us to make better choices for our health. From maintaining a balanced diet to regular exercise, small steps can go a long way in supporting these vital processes. If you like our video, do subscribe to our channel and to stay updated with our latest videos.